Every year, coastal storms push walls of water onto shorelines around the world. Storm surge, ocean water driven inland by hurricane-force winds, can raise water levels by 30 feet or more, destroying buildings and flooding entire communities. Nearly 40% of the world's population lives within 100 kilometers of a coast. The United Nations has identified floods and tropical cyclones as some of the fastest growing sources of economic loss on the planet. Governments are spending billions on seawalls and breakwaters to hold back the water, but there is a defense system that has been there for millions of years, and we are losing it. Coral reefs are the first thing a wave hits before it reaches shore. The reef crest, the shallow, seaward edge of the reef, is where most waves break. A 2014 study published in Nature Communications found that reef crests alone dissipate 86% of incoming wave energy. After passing the crest, waves continue across the reef flat, which dissipates 65% of the remaining energy, most of it within the first 150 meters. The whole reef reduces wave energy by 97% on average. During Hurricane Wilma in 2005, incoming waves reached 13 meters. The Mesoamerican reef cut that wave height by 99%. Reefs become more effective as wave energy increases. Breakwaters do not work that way. Governments often respond to coastal flooding by building breakwaters, which are concrete structures designed to absorb wave energy. Coral reefs do the same job. The average wave height reduction for reefs falls in the upper range of what artificial breakwaters deliver. But reefs are cheaper. The median cost of building a tropical breakwater runs around $20,000 per meter of shoreline. Restoring a coral reef costs about $1,300 per meter. A study of 8 Caribbean nations found that reef restoration was more cost-effective than breakwaters in every single country. In the Maldives, Bali, and Cancun, reef degradation has already pushed governments toward artificial defenses. Those structures protect shorelines but cannot support fisheries or the ecosystems coastal communities depend on. The reefs that protect these coastlines are disappearing. Rising ocean temperatures, pollution, and bleaching events are killing coral around the world. The Maldives, one of the lowest lying nations on Earth, has already survived 2 major bleaching events and expects another. When reefs degrade, the protection disappears with them. In the Maldives, reef loss has led to measurable increases in wave energy reaching shorelines. Up to 100 million people live in low-lying coastal areas within 10 kilometers of a reef. Indonesia, India, and the Philippines account for roughly half of that population. If the reefs go, someone has to pay to replace them. The Maldives Coral Institute is already working on a solution. Researchers there are building coral-friendly coastal defenses, structures that combine the durability of concrete with the wave-dissipating qualities of living coral. Restoration projects in the Maldives have shown results. In one site, live coral cover increased by 45%, and fish abundance increased by 700%. Reef restoration is not just cheaper than building breakwaters, it rebuilds a living structure capable of self-repair. The Ferrario study argues that restoration efforts focused on the reef crest, where wave energy reduction is greatest, would deliver the most benefit for coastal communities. The reefs are already there. The question is whether they will last.